Hi, today I want to talk about the reading and writing to a binary file, basically talking about the binary file and how we're going to apply that to our image processing that we are going to do this week. So let me share my screen. So we want to start with binary versus the text file. So the text file that we have been working on and we have been doing it is basically characters. It's for the human to read and write characters. And that's what we are processing in any language that we have been doing so far. That's what we were doing. But when we're talking about the binary, the format of the file can be saved as a binary. We saw it in the sound, we saw it in the image, we saw it in different ways of doing it. So whenever we're talking about digital file, that is basically a binary file that's going to be saved as zeros and ones. So if you open that binary file in a text editor, you're going to see all kind of weird characters because it's trying to take that binary, change it to a character, and we get all kind of special characters and those things. And definitely we cannot read it like that. So first, let's go over what the binary file, basically the binary is. So when we're talking about binary, we're talking about zeros and ones. You know that already. And 1 byte is basically 8 bits. So when we are talking about 8 bits, we're talking about a bunch of zeros and ones that's going to be together to create 1 byte. Now, we using a regular number, I'm going to call them decimal number uh, or Arabic number or whatever we want to call it. It's the base 10. So when we are talking about our regular numbers or base 10, that means every time we take the number, we go from the right to the left, we are multiplying it by 10. So basically it's 10 to the 0, 10 to the 1, 10 to the 2, and so on. So if I have a number like so if I have a number like 235, that's basically 5 times 1, 3 times 10, 5 times 100. As I go right to left, I'm multiplying by 10. Now, if we go to the binary, binary is base 2. So base 2 means we don't have any digit that's called 2. In base 10, the digits are 0 to 9. So in base 10, we don't have a single digit called 10. In base 2, we don't have a single digit called 2. We have zeros and 0 and 1. So that means my numbers can have only 1 and 0. Now, because this base 2 is multiples of 2. So if I go from right to left, I am multiplying them by 2. So the first one is multiplied by 1, which is 2 to the power 0, 2 to the 1, 2 to the 2, and so on. So we're multiplying by 2 as we go to the right to the left. So let's look at what we have over here. I just put a sample of it there. So if we are looking at this, I'm just going to put, instead of thinking about what is 2 to the 0, 2 to the 1, I'm starting with 2 to the 0, which is 1, and I'm multiplying by 2 as I go to the left. So whenever I want to calculate this from the binary to the decimal number, what I'm going to do is I'm going to take these numbers and I'm going to multiply by what the base is going to be. So we can think about it going this way, 1, 2, 4, and so on. So this is going to be 1 times 128, 0 times 64, and so on and so forth. Now, if we add these things together, that's going to give me a decimal value of this. Let's see how fast you can add up these numbers. So 128 plus 32 plus 8 plus 2 plus 1. So for me to make it a little speedy addition, I'm going to add 2 to 128. That's going to give me 130. 32 plus 8, that's going to give me 40. So that's 170 plus 1. So this is going to represent 171. So when you get a chance, just put the ones in all of them to see what you're going to come up with. So that means I have to add all of these things together. So if I add all of these things together, I'm going to come up with 255 number, 255. And if I calculate, consider that they can be all zeros, then the number that I'm going to have in one byte, from decimal point of view, is going to be from 0 to 255, which is 256 combination. So I have all zeros, and I can change the order of these ones, and I get up to 255. So I have 256 combinations of it. So if I am reading in as a byte, so remember we talked about binary reading, that would be base 2, and decimal reading, which is base 10. Now, if I'm reading in bytes, so the binary files are saved as byte. We're going to read 1 byte at a time. So a typical integer is 4 bytes. That means I'm going to have 4 byte of numbers to create one integer for me. So in that case, if I take 4 bytes, then I am going to be multiplying it by 256 because that's going to be my base. So each one of them is going to be 256. So I'm going to take the 64 times 1, 226 times 56. As I go this way, I'm multiplying it by 256. One of the things that we got to consider when we are reading binary file, or basically whenever we are processing anything internally in the computer system, it is backward. So the memory is from the bottom to top. Anything that we're doing in the computer side, computer inside, it's going to be backward. So that's something that we have to keep in mind, not to confuse it too much. If you take the assembly language or courses like that, you're really going to get into it. I'm just going to remind you once in a while that things are going to be backward. So meaning that the number that I want, 123,456, is if I take 4 bytes, it's going to go from this point to this point, not from this point to this point. So basically, this is my rightmost. Remember how we were doing our rightmost multiplied by 1? So this is my rightmost. So basically, it's backward. So my 4 byte, I have to take it, I have to switch it, then I create my number. The good thing about computer science is we don't have to remember all of these things all the time. We just think about it once, we put it in a function, we write the code, and then we're done with it. We don't have to come back and rethink it again. So that's the way we're going to be calculating these things. Let me clear these things out. So if I have a file for binary, I am going to be putting a word B for binary. So when I'm reading or writing, I can do read or write as a binary. So that means I'm going to open it up and I'm going to be reading it as a binary. I'm going to be writing it as a binary. Now, I'm going to read 4 bytes. Remember the way that I'm going to create any kind of a number or integer, I have to read 4 bytes. And this is the way that I'm going to be reading 4 bytes. So I'm going to open the file. I'm going to read 4 bytes. And basically, that's going to give me a list of 4 elements from 0 to 3, which is going to be this one right here. So any of them is going to contain integer between 0 to 255. Of course, it's in the binary. It is in byte. So we have to translate that, and we're going to learn how to do it. Now, if I want to write to the file, I'm going to get my list. I'm going to change it to byte. I'm going to typecast it to be byte, and then I'm going to be writing it to the file. Okay, So next topic, we're going to talk about the random access. So far, what we learn in our uh, file processing is we open a file, we go to the top, and we're going to read the sequentially. So if I want something in the middle of the file, typically so far I couldn't jump into the middle of the file. I had to read everything up to that point, then I can read it. And if I want to go back up, I couldn't go back. I have to close the file, go from the top, and I start reading it again. That is called sequential, and that's the way we were doing it so far with all our file processing in different languages and everything. That's what we were doing. Now, with the random access, we can go to a specific position and we can start reading it over there. Remember, we are talking about bytes. So if I say we have something in Python, and of course this is available in C++ and Java, we can do the same thing in those. So the SIG is not coming from Python, it is in other languages too. So the SIG is going to go change the pointer to this position. Remember, when I open my file, I'm going to be in position 0. So we're going to talk more about that. So if I want to go to position 255, I'm just going to put it over here. Now, there are, this SIG is overloading a function. That means I can put a number in there. And the SIG current is the current position of my pointer, where I am, my current position. So if I say SIG for in file dot SIG for SIG current, is going to go from the current position and it's going to move forward 4 bytes. Remember, these are all in bytes. So we're going to go forward and we can go backward. So we can go -3. So from the current position, I can go backward, forward, or if I have another position, I can just jump into that position. And if I am processing and I don't know where I am in the file, I can get my position by tell. So the tell function is going to tell me what is my current position. So when we are doing the image processing or basically anything except the plain text, they have some headers on the top of the file. So the difference between the PDF and Microsoft Word is they have stuff on the top of the file that's going to define things that how the file, the data is organized. So on the top of the file, the difference between different files is they have a different headers. They're going to say, how do we navigate this file? So for our basic image processing that we are using BMP in here, the BMP is a basic one because we starting to learn this. We want to make it the simplest format so it doesn't get too complicated. Of course, if you want to do the other formats, you have to go see what the header is and they might be different. So there are some information on the top of the file. So when you open the file, you can read some information about the file. So the way that it's set up, if I go to the position 2, I can know about the size of the file. So I know how big the file is. And position 10 is going to tell me where my image data is stored. Remember, I have a header section and I have a data section. So if I think about it as a file in this format, then I have my header section, and then I have my data section. So my header is right here. I'm going to be reading the data for my header, and then my actual data is going to be right here. So it's going to tell me where my data starts. And of course, the width and the height of my image in pixels. And we're going to talk about the pixels also. So we are talking about 4 bytes for integer. And as I said, things are backward. So when we are reading 4 bytes, we are reading and writing it is going to be backward. So it's like we do the first byte and second byte and third byte, but it's on the other order. So the very first one is going to be my rightmost byte, and then the last one is going to be the other. So as I go from the left to right here, which in our regular human thinking is from right to left, again, that's going to be a little confusing, but you don't have to worry about it too much. We're just going to go over it. We're going to write the function for it, and we're going to get done with it. So the base here is what? What is my base over here? My base is 256, and that's why when I start from the left going to the right, I'm multiplying it by 256. So now let's think about a function that can do this for us. We put it in there and we don't have to think about it anymore. Now let's go over this function, which all of these material are coming from Python for Everybody version 3. So we're going to be doing the read first. We're going to read 4 bytes. So we have 4 bytes in here. Now we're going to have our result. Remember, we're taking the byte, we're changing it to a number. A starting point, the base is 1. And we're going to keep multiplying it by 256. As we go forward, we are multiplying by 256. So we are moving through this 4 bytes. So remember, we have it as a list here. So we're starting with the 0, 1, 2, 3, and then we are adding it to the 0, multiplying it by base. So that's the way we're going to be calculating our integer or number. So remember what we had the size of the file in bytes. So if I want to calculate that, I need 4 bytes to know what the size is. I need 4 bytes to know where my starting data is. I need 4 bytes to know where my pixels are, the width and the height of it. So the coloring for the basic coloring that we are using in BMP is called RGB, red, green, blue. So that's 3 bytes. And each byte goes from 0 to 255. 0 to 255. Again, when we are processing these things, it's going to be backward. So when we are looking at our data in one line, we have to keep in mind 2 things. One is 1 pixel contains 3 bytes, and each byte is RGB, red, green, blue, but it's backward. So the first 3 bytes, 255 to 550, for us to understand it, is actually 0 to 55 to 55. But again, we're going to write the code for it. We're going to put it in there. I don't have to worry about it anymore. So the 3 bytes for my pixel is stored in backward position. So I have 1, 2, 3 byte of information over here. Now, every row has to have enough byte to be divisible by 4. That way, the formatting of it, that way the calculation of it, we don't have to do different ones. So if they don't do this divisible by 4, then the sizes are going to change of each line, and then for each picture, and then you had to figure it out. and it would be a lot more processing in there. But when we're making it divisible by 4, we know every line is divisible by 4. We go to the next line, we go to the next line. So in this case, I have 1, 2, 3 pixel. 3 times 3 is 9. So 9 is not divisible by 4. We have to put some padding to make it divisible by 4. So in this case, the next divisible by 4 is 12. So we're going to put 3 extra byte in there. It doesn't have anything in there in your project for encrypting code. You can actually see if your image has padding, and you can go in there and put your secret code in the padding instead of randomly go anywhere. Because that way you're going to be sure that your image is not going to be modified. So not necessarily every image going to have this padding though. So if you want to use the padding, you have to find an image that has the padding, and we can figure it out. So each one of them is going to be 0 to 255. So if I have 0, 0, 255, that's going to give me blue. If I have 255, 0, 0, that's going to give me red. And this is the one in the middle. So 0, 0, 255, it's how we see it as a 255, 0, 0, which is going to be red. And 128, 128, 128, which is backward of the same thing, is a gray. So again, we don't have to memorize all these things. We have seen it already, but that's what we have. So your book has a very good picture of how these things are all stored. So we have a section called the header. This is our header. So in the header, we have some information about the file. So the first 2 bytes is left alone for some emergency or whatever we need in the future. So our file size start at position 2. And you can see that our file size have 4 bytes. So if I go to position 2 and pick up 4 bytes, that would be my file size. If I go to position 10 and pick up 4 bytes, that would be the position of my pixels, starting pixels. So this number is going to tell me where to go to pick up my colors, my pixels. And of course, position 18 is going to be the width, again, 4 byte. And position 22 is going to be the height of my image. Width and height is right there. What else? So this is the 24-bit true color. That's going to be RGB format. 3 bytes, 3 times 8 is 24. So here we can, so far every time we were doing a file processing, we had to open it either for reading or writing. We couldn't do it at both. So if we were reading a file, we had to read it, close it, open it for writing. But here we can actually open a file for read and write. So we're going to put a plus over here to say that not only I'm going to open this for reading, I'm going to be writing to the same file. So most of the time what we do with a pixel, we can pick up 3 pixel for, 1 pixel, which is 3 byte, modify them and write it back. So if I want to start getting the image information, I have to know about the size, the number and my offset, and I go to that location. That's where my data starts. So we're going to be writing a function to do that for us. And the function, we're going to call it read int. Again, We're going to create this one time. We're going to put it somewhere and we're going to be using it all the time. I don't have to worry about it anymore. So to read my header, I'm going to go to position 2 of this file, and I'm going to call this function. So this function is going to have two things. One, the file, and two, the position that we're going to be doing. So this read int is going to go to position 2, read an integer of this position, basically 4 byte, translate it to integer, and return it. Then we're going to go to position 10. We do the same thing. Position 18. So the process of all of these things are the same. We just need the position, and then we're going to read 4 bytes and translate it to integer and return it. So this is the function we're going to create. That's going to work for all of them. We're going to get a position here. I like to call it position instead of offset so it doesn't interfere with the offset that we have over there. So we're going to get a position. We go to that position. How do we go to that position? We're going to be using the offset. So we're going to go to this offset. So we have to know what the offset is, 0, 2, 10, 18, 22. We're going to go to that position, and we're going to read 4 bytes. So if I'm in position 2, the 4 byte is here. If I'm in position 10, the 4 byte is over here. So we're going to take 4 bytes, and then we're going to process them the way that we were doing it earlier. Remember that 4 bytes are going to be base 256, and we did it backward, so that's the way we're going to calculate. So we have this function that's going to do our read int. That way, I don't have to worry about it anymore, how the order is, how it is. I'm just going to go to that position, and basically, I am going to be doing these things, read int, read int, read int. And now I have my file size, my starting point of my image, my width, and my height. So now that I have my starting point, your book is putting it called start position. I'm going to go to that position, and I'm going to start reading my pixel. Remember, every pixel has 3 bytes. So I am going to go here, and I'm going to pick up 3 bytes. Then I'm going to get another 3 bytes. And again, these are backward instead of RGB. So it's RGB, RGB. So it's backward, but we figure it out. So we're going to go to this position. We know what position it starts, the header is giving us. And then we're going to start reading the pixels. So we know the height, we know the width. We're going to start reading from the, again, because this data is backward, we're going to go to the bottom of the file and reading it up. So this position is this row is the bottom of my image, is not the top of my image. Everything is upside down. So when we process those pixels, which have 3 bytes at a time, we are going to be skipping the padding. So we're going to read, 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 and then we're going to skip the padding. So how do we skip it? We're going to calculate the padding somewhere. We're going to know each image is different. So we're going to figure out the padding in our program. We're going to learn how to calculate it. It can be 0, can be 1, 2, or 3. So depending on how much it's going to be, to make this whole row divisible by 4. So that's going to skip over to the next line. So we're going to keep reading these pixels, and then for every row, we have to skip over the padding, go to the next one. And that's what, when we're done with the column, we do this to go back to this. So we're going to get the file size, we're going to get the starting point, we're going to get the width, we're going to get the height. So when we are, so this is how to find our padding. So our padding, we're going to do the line size, the width times 3. So we have the width, we multiply it by 3, and then we're going to check it to see if it's going to be divisible by 4. If the width that we have multiplied by 3, remember we have every pixel has 3 bytes. That's why we are multiplying by 3. So width is in the pixel, we multiply by 3, so we're going to get every the width in byte. Now we're going to check it to see if it's divisible by 4. So if it's divisible by 4, my padding is 0. I don't have no padding there. If it's not by that, we're going to get the %4 and we deduct it from 4. So that's what the calculation of the padding is. Now I know what the padding is. Now I can skip over it every time that I get to the end of the line. So every pixel, remember what we're doing here is we're putting every task in one function. So we're focusing on one task in one function, and that's the goal of you writing your code, to be sure that you break down everything to functions and then you focus on one function at a time. So this function job is to get the pixels. So if I want to process my pixel, first I have to read 3 bytes, because I'm going to read 3 byte in 1 pixel. Remember RGB, of course, we're reading it backward. So the 0 is my blue, the 1 is my green, the 2 is my red. So backward of RGB. Now that I have my, so I am, how do I get to this? It's not a concern over here. This is the concern of just reading the bytes of 1 pixel. So anywhere in the image, when I need to process my pixel, I'm going to call this function. So that's the way we're going to process it. And remember, if I want to go every time so when I am in the location and I read 3 bytes, I moved forward 3 bytes. If I want to go back to the same location, then I have to use -3 for my sake to go back. So in some programs, you might want to get the blue, green, and red, modify them, and put it back. And remember, we open this file for reading and writing, so you can read and write at the same time. So if I get the blue, green, and red, and I modify them, and I want to put it back in the same location, so I'm going to do -3, go backward, and write it on top of what we had before. So that's what I have for this, and then we can talk about your specific program. So for the image processing one, what I was asking you to do is to go and write into this file. So when you open your image, you're going to have something like this. So if you go and pick up one of these pixels and modify one of these byte of the pixel, even if you modify all 3 of them, then if you have a big image, it doesn't show. So you have the option of how to go and modify this. Maybe I just create another one, how to do it. Okay, so I'm going to close this right now, and